In this segment, we're going to learn how to use the superheated tables and the compressed tables for water. Remember, this is for water. There are other tables in your book that look very similar, that are read in exactly the same manner for other substances. This is just for water, so always be aware of what substance that you're working with. So let's look at the compressed tables first. So this would be on the left-hand side of that vapor dome. You can find this information in table A5 and A5E. The E would be for the English units. So, all right, so table A5. If you look at this, you'll notice that it's organized in blocks of pressure. So all you need to do is just go to the block of pressure that you're at, right? So let's work a problem. Given we've got water, our pressure is 2.5 megapascals and the temperature is 80 degrees Celsius, and I figure out that this is compressed. We'll figure out in the next segment how we know whether or not something is compressed or superheated or two-phase or what have you, but let's just take it on faith that it's compressed. And we want to find the specific volume. All right, assumptions. I don't really need to make any assumptions. I don't need to simplify the problem anymore. I'm just looking at property data. And as you remember, because you read the syllabus, this is how I want problem solved. You list your given, find, assumption, and then solution. If you don't have any assumptions, just don't list any, but make sure that you put it there so that I know you didn't just forget about it. All right. So table A5, just go to the block that corresponds to 2.5 megapascals. There I am. There's my block. And you'll see that I have a column for specific volume and a column for temperature. All right. All I need to do is go down to the temperature of 180 degrees Celsius and read off the corresponding specific volume. And you'll notice that the specific volume is written as a number times 10 to the third. So the actual value is 0.0011263 meters cubed per kilogram. Super simple. One last thing, you'll notice at the very top it says TSAT equals 223.99 degrees Celsius, and then you'll see SAT at the very bottom of that temperature column. So this is the saturation temperature at 2.5 megapascals. And I would encourage you to go and look in your saturated tables that are organized by pressure for water and verify that that's the saturation temperature that you see. So the compressed tables, they give data in the compressed region all the way up to that saturated liquid line. All right, superheated water tables. This is table A4 and table A4E. Would be for English. And they look a lot like those compressed tables. And that's because they are. They're organized. I mean, it's not the same data, but they're organized the same. They are organized in blocks of pressure. So all you need to do is go to the pressure that you're at and read off the value that you need. So, all right, given, find, assume, solution. We've got water, pressure is 35 kilopascals, temperature is 200 degrees Celsius, and I figure out this is superheated. I'll figure out how to do that, how to do that in the next segment. But I need to find specific volume. I don't really need to make any assumptions. I'm just looking up data in a table, and now I'm ready to do my solution. So I'm going to look at my superheated water tables because I've figured out that it's superheated. And I'm at 35 kilopascals, which is equal to 0.035 megapascals. Awesome. So I just need to go find the box that corresponds to 0.035 megapascals. There it is. And I've got a column for specific volume, and then way over, I kind of have to look over a little bit for that temperature line or temperature column, but there it is. And I just need to read off at 200 degrees Celsius and 35 kilopascals, what my specific volume is. And it looks to be 6.228 meters cubed per kilogram. You'll notice at the very top, it doesn't say 10 times 10 to the third. So that number is just what it is. Okay, well, I hope that was helpful.